Okay. Hello, hello. Let me know if you can hear me. Testing. Alright. Well, thank you for coming. This is Junichiro Horikawa. This is a tutorial live stream for Houdini. It's been a while from last time I did it. Now, I would like to continue doing this with some break, after some break. Okay, so let's start this. With me. Oh, should I raise up? Let me see if I can raise this up a little bit more. Okay, how's this? Alright. Well, thank you for coming. Now, today I am going to show you a algorithmic way to create a smudge tool effect, which you would see in Photoshop tools. There's a tool called Smudge which works on 2D, but the same algorithm. I mean, I'm not sure what the real algorithm is for the smudge, but I could simulate such a effect, and if you can do it on 2D, you could also do it on 3D, and that's what I'm going to show you today. Just like this. I mean, this is just a smudge tool, just pressing the texture or color with some brush ball like these, splitting the color like with your fingers or something like that, with some brush. So that's what I'm gonna show you, and I'm gonna start by using 2D plane to test and extend it into 3D geometry. Okay. And also, let me explain the basics of this algorithm, how it works. Okay, so the main concept is using a simple vector mathematic with the color mixture. Okay, so first you have some kind of a geometry or plane with the colors. Okay, consider this is a plane with the colors, any color, and on top of this plane you're going to draw a stroke, which is going to be a stroke curve for a brush or smudge tool. And you define some radius for the smudge tool and run this through the stroke from start to end. And based on this stroke, what I want to do is to mix or doing the smudge effect within these areas. Now, basically, if you look at close enough, the basic algorithm is that you have a vector value which goes through the stroke and you pick the color which is on the current positions of this vector position right now, and then using some kind of moving value to move this point step forward to this direction, then pick the color at this point as well. Let's say this is green, let's say this was purple. Okay, and what you're going to do next is to change this color here by mixing green and purple or blue with some ratio. Could be 50-50, could be like 40-60, something like that. And you could have some threshold parameters to change those ratio, how much it mixes with different colors. In reality, I think when you mix the color between the darker colors and lighter colors, darker colors will have more effect, or more darker color will be affecting lighter color more, I think, when you mix the color. For example, if you mix black and white together, you'll see a bit darker than like 50% gray color. So let's try to set some parameters how much you can mix between those colors. One that's behind, the one that's forward. And that's pretty much it. Other than that, you can use a parameter for the brush itself. You could make it soft brush, or you could make it hard brush by creating some strength from the center to the border of this brush. If the strength, if it's the hard brush, the curve, the map of this strength will be, if this is X and this is Y, the strength will be like straight line like this. If the strength is going to decrease linearly from center to the border, then the curve will be something like this. Or you could make a softer brush, something like this. So these things could be done using ramp parameters, I think, so let's do that as well. So these strengths will going to affect how much will mix between these two colors to create more natural blending between the one that's behind and one that's forward. Okay, so that's my plan, and it's pretty simple. So let's do this from scratch. Start with the 2D plane, then try to extend it into 3D later. Okay, let me first save this to the today's folder. Where is it? Okay. Right. And from today I'm going to use Houdini 20, which doesn't really matter in my case because I'm mostly using Vex, so I think it still works on Houdini 19, 18, 17 maybe. But just as I like the new one, I'm gonna try with the Houdini 20. I also like using Calma these days, so if I have time, I might want to use that as well. Okay, so making geometry node. I'm gonna start by creating a grid. And since I am going to blend the colors on a point position, I mean each point attribute, I think it's better to have a decent number of points, meaning the resolutions for the image. So I'm gonna say 50 to 50 for now. And let's apply some texture to this as a point color attribute by using attribute from map. Okay. And well, this default thing is okay, but let's use something else, shall we? I'm gonna try to find some copyright free image. Let's see, where should I find it? gonna go to the pixels, which should have some free copyright free image. Let's say dog. Okay. This guy, or any one is fine. It's a bit hard to choose. Shall we choose this guy? Okay. Hey, thank you, Bruno Salvera. I would like to use this one. Okay, now let's bring this to the folder for today. Okay. Now choose that image. Now the image has been skewed a little bit, so let's change the size a little bit. Yeah, something like this. And let's also change the resolutions. So this is X, which is for the column, so I'm gonna make it 750. Okay, so I think it's enough resolutions here. Let's try, and I'm gonna delete the default light for now to see the changes better. Thank you for all thank you all for coming. The comment, what are your thoughts on Kalma in terms of film production rendering? I'm not sure, I'm not in the film industry, so I don't know how it is beneficial to film industry. I am just in an architectural field. So but I thought it's more logical than mantra, and I think it's faster, so I like it better than mantra for sure. I used to use Redshift since it's really fast, but the setup is a bit takes a little bit of time because you have to install each plugin for each version. So I mean, I like using Kalma because it's out of the box. You can use it out of the box. Talking about Houdini 20. Curious if you play with OpenCL sub in the future. Looks cool. Yeah, I am interested in OpenCL as well. For sure, I would like to use it in some in the future for sure. Can this 3D smudge effect be used for flood related sims? I think so. I mean, you can add a custom behavior to the fluid and use the similar stuff, similar algorithm, which I'm going to show you today. So I think it's possible, transferring the color, mixing the color based on the particle positions and so on. Okay, so where was I? So I have this 2D plane with the color. Let's check where it is placed in the geometry spreadsheet. Okay, so it's on the point attribute, so that's fine. Now next I am going to create a stroke curve on top of this plane where the brush is going to run. It could be random. You could also input the curve you define. Let's draw some curve for now. I'm gonna draw Bezier curve. Oops. Okay, so let's say this is a stroke that I'm gonna use to run the brush. Goes from here to here, and I think it's better to have a multiple number of curves so that you can assume that you might going to have multiple curves, multiple strokes. So let's create a new curve as well. Yeah, something like that. Okay, I'm going to cut this, place it inside this geometry node. Oh, the position is a bit off. Okay, let me also move this. To place it on top of the surface. Okay, somewhere around here. Okay. Now, it's better you convert it into a polyline so that you can, it's more easier for you to get the positions based on the timeline. So, we sample. And let's make this subdivide curve. Don't really need much points. Okay. And how many curves do I have? 2. Okay. So I think that's good. Now next, I am going to, let's say, I have to decide where shall I create the animation for the stroke, meaning when to move the brush. If it's outside the solver, then you have to use some expressions to place the brush. If you do this inside the solver, then you could move the brush positions iteratively. So I guess I'll do this inside the solver. Okay, now since I want to move this point as well as changing the color for this plane as well, I think I have to merge these together to place it in, connect this to a first input, since 2 of them are going to be updated. And well, thing is that the points that I'm going to move is not really a curve, so maybe I can connect this to a second input as a reference, and I can just add a starting point of this curve to this merge, which is going to be the position for the brush. Okay, so let's create a starting point positions. What's the best way to do that? I guess I'm going to use a primitive wrangle. Get start. Just pick a bunch of points from the primitive using prim points. Oops. Then pick the first one, get the positions for this point, and then add it. Okay, then remove the primitive itself, which in this case a curve. I guess there are more simple way to get the starting point. these are the starting point. Let's connect this to here. And let's have some group informations for those two geometries. One for the plane, one for the brush. So I'm going to create a group for the brush. For the points, I'm gonna call this brush. And for the plane, I am going to create another group named grid, and in this case primitive. Okay, so this is the grid primitive, this is a primitive group, this is a point group. Alright, now we are set. Let's try to implement this algorithm. Okay, let's see. So get it inside a solver. First thing you want to do is to move the brush with the stroke with some specified speed. Okay, so let's do that. The curve, the reference curve coming from this second input here. Yep. And what I want to do is to move the point which has a group called brush. Yep, this one. So let's try to move the brush with the stroke here. Okay, so you would need to specify the speed and yeah, just the speed to move the brush. If you want to move it not linearly but faster in some faster in some positions, slower in some positions, you might need to use something like a ramp parameter, but I'm gonna make it simple. I'm gonna use a linear speed here. Now before doing that, I think it is better go back to the curve itself and have some additional informations to this curve, such as the total length of the curve, so that you can use it together with the speed, how much the point has been moved. So let's do that. Also, by clicking the resample, you could add some useful attributes, something like curve U, tangent U. So I'm also going to add these as well. Okay, now I am going to use the measure node. Get the parameter informations, which gives you a total length of the curve for each curve. Okay, so now that I have enough information, let's go inside the solver to try to move the brush with constant speed. So start by creating a speed attribute or variable. And the speed is going to be a step length for each frame. Okay, so for each frame I'm going to decide how much it moves, how much length it moves. So that's going to be the speed. So let's try with 0.1 for now. It might be too big, it might be too small, depending on the length of the curve. Okay, now next I am going to get the current point position. Get the UV information from the current point position of the brush, and try to get the UV information for each brush, which should be on top of this brush curve, a stroke curve. So you can do that by using something like prim UV or what was it, XYZ distance. Okay, so the XYZ distance functions will give you a closest primitive, closest vector value. Well, and in this case, actually each point, we know that each point belongs to which primitive, which I might also want to have that information supplied to each brush. Right now, I do have this brush information, but doesn't have information which point belongs to which stroke. So let's have that information as well. Let's add set point attrib. I'm gonna name this stroke attribute to the new point. And this is just going to be the primitive number, which is the number for the stroke. There you go. So we have 0 and 1. So we can use these informations to specifically get the UV for each stroke, for each brush point. Okay, now let's calculate the distance xyz dist coming from the second input. What's the parameter? So we have this prim group, and this is where you can filter which primitive to look for each point. So 1 I2A, convert the stroke attribute, which is a primitive number, which is going to be used as a primitive group filter. Then use the current point position of the brush point and output the primitive and UV. Now we know that this prim out attribute, or I mean variable, is going to be same as this one. So we're not going to use this one, but we're going to use this one, which gives you the UV informations all on the curve. And then you could use that informations to have the positions by moving this point through a stroke with this speed. Okay. I think, yeah. Now that I'm using this, let's see. Actually, I wanted to use UV sample instead of prim UV, but I don't think this works with the curve. Let me just check. Yeah, I don't think this will gonna work. This is gonna work. So, okay, never mind. So I have this distance, which I'm not gonna use because this is equal to 0. Now what I'm going to use is this UV value, and by using this UV, you'll be able to get the current point position, which is this one. But you could also estimate the point position going forward through the stroke by using the perimeter attribute in some way. So the current perimeter of the curve is prim perimeter so this is going to be the curve belongs to this brush. Curve length belongs to this brush, okay? And the UV in terms of the curve, UV is just the x value going from 0 to 1. Okay, 0 is the start point, 1 is the end point. And hopefully, since I have resampled the curve, the U distribution is linear. So what I could do here is to estimate the current point positions as UV could be defined as uv.x uv.x multiplied by perimeter. So this will gives you the distance from the starting point to the current point positions. Okay. And then by adding additional lengths, in this case speed, you'll be able to get the lengths, the curve lengths a bit forward from the current point. So what I mean is that if you have a curve like this, and if you have the positions right here, currently you only have UV value, which in this case something like 0.4, 0.3 and 0. And in terms of the curve, the x value, the u value always changes. Right. And since I have the total length of the curve, which is L, if you want to know the length from the starting point to right here, let's call this A, which I'm gonna call this length as L dash. Now L quote is equal to L multiplied by 0.3 in this case, because this is the 30% positions from 0 to 1. So if I have this length here, I can also add a speed value here, how much you want to move from this point positions to forward. This is going to be A quote. So A quote positions is going to be the length for the A quote. It's going to be L quote plus speed. Right. So now you need to convert this back to a UV. So you just need to divide L speed. L quote plus speed divided by L. I shouldn't have choose this color. It's a bit hard to see. Okay, and this is going to be the new U value. Okay, for this new point. So that should work. So this is the length for the next positions, and the new U is a next length divided by the parameter. Okay, now I can estimate the next positions by using prim UV and the name of the primitive, I mean the number of primitives, stroke, and set new U 0 0. Okay, I think I'm missing something here. What was the parameter for the prim UV? Okay, I forgot to set the attribute name, so need to get the point positions. Okay, seems like I'm still missing something. Let's see, prim UV. So the input number, attribute name, primitive number, and vector value looks correct. What's the error here? Oh, okay. Just needed to activate this. Okay, so this should be it. And finally, update the brush point positions with this next pass. Spell mistake. Alright, so let's check. It's a bit hard to see the points, so let's copy the sphere on top of this brush. Okay, let's check. Starting from the sun, let's also show the curve as well. Let's raise this curve a little bit up so that we can see this a little bit clearly. Okay, now let's see what happens. Okay, so it's moving. It's a bit slow because of the high res. Maybe I'm going to reduce the resolutions a bit for testing. So I'm gonna call this 300 and I'm going to copy this value. And a multiply x divided by y. Okay. Okay, so this is the speed of 0.1. It's moving linearly. Let's try to change the speed, see if it's gonna work. Let's set this to 0.4. Alright, so this work. In the end, it just stops. Okay, now I'm good with these. I'm gonna keep it to 0.1 and try to create a setup with this example. Now that I have moved the brush, I am going to try to create a mixture algorithm, a smudge algorithm, which is the main topic of this tutorial. Hey, thank you, Horst, for kind words. Okay, thanks for coming. It's great to have you all. Okay, so I'm going to use a point wrangle for the smudge. And I'm going to try to make the code versatile so that it could work on three-dimensional geometry as well. Okay, so first off, let's define the radius of the brush, which you could set it here or you could set it outside. I mean, if you want to change the brush size interactively or by animation, you should do it inside the solver. If the size is constant, you could do it outside. Now, which should I do? Maybe I'll just do it inside the solver to make it a bit more interactive. So, the brush radius. I mean, I think it makes sense to set the brush radius for each one of it. So let's do this here. Or maybe I'll just create another point wrangle. Okay. Now, I don't need the speed parameter anymore, so let's delete it. Things that I noticed is that in Houdini 20, if I use this parameter promote button, the attribute starts to, the parameter starts to appear here instead of the bottom. So first time I used this, I was a bit confused. Okay, so let's start with a constant brush size, shall we? Later, maybe we can change this to something else. I'm gonna call this radius, brush radius. Okay, so let's say like 0.3 for now. And let's apply this as an attribute to each point. Something like that. Yeah, simple as that. Okay, now let's go to the smudge tool. try to create a smudge algorithm code. Okay. So first thing you want to do is to, based on the radius for each brush, you want to look for, you want to know which part is going to be color mixed and which part is going to be ignored. Okay. And for this one, I think I need to apply the point triangle code to every point instead of the brush. So I should choose grid, although the grid was the primitive group, so maybe I need to change this after all. I'm going to change this grid to point group so that I can use this here. Okay. Now for each points belongs to a grid, I'm going to search if there are any brush nearby to each point. Okay, by doing near points function. Looking for a group called brush. With the current point positions with the radius. Okay, well, one thing I was missing is that I cannot really use this NPTS function for this radius because the radius is different for each point. That now that I realize. Okay, so instead of doing that, I think I should do something else. Maybe what I could do is to get the old stroke points first. I mean the brush points first by using expand point group named as brush, which will give you a list of brush points. Each point has different, consider each point has different brush radius. Maybe better using some randomness here so that it'll be easier to see. I'm gonna use the stroke number as a random seed so that it's constant based on the primitive number. And let's make this from 0.5 to 1.5 or 1.0. Okay, and let's set the maximum to 0.4. Right, so each brush point should have some random radius. There you go. Okay, now based on this I'm gonna look for the point which is close enough to the brush for each grid points. Now I'm going to loop through all the brush points. Get the point number, get the point position, now let's calculate the distance between this position and the current point positions, and if it's smaller than the radius belongs to this brush, then you're in. It's time you mix the color. If not, then no, you're out. So distance between the pass, or maybe I could, well, yeah, let's just do this way. It might the one thing that I'm wondering is this way of writing the code might gives you a high cost of calculations. So in those cases, I might need to change some code to optimize it. But for now, as a testing, it should be fine. Meaning it might going to be slow. Okay, so first calculate the distance and check if the distance is smaller than the brush radius. And the brush radius can be retrieved from the attribute. Yeah. Okay, and if the distance is smaller than the radius, then those points are going to be used as a smudge target. Okay, so in order to do the color mixing now, as I said, you need to have the previous point and the next point position. Okay, so before moving the brush, you need to store the previous point positions. Where was it before? So I'm going to create a additional attribute inside a move brush called prev pos before updating the point positions. Okay. Now you have the previous point position and the next point positions, which is the current point positions. Okay, so based on those informations, let's see how we can mix the color, shall we? Okay, so first let's get those positional information. So bpos is the current point positions. Let's rename this to something easy to understand. bpos now. And you also have bpos prev, which is stored inside prev pos. Okay, also need to rename it here. Now, now that you have two informations, it's time trying to do some mixing. Okay, so how shall we do this? Let me check what I have written here. So first of all, as I said, I want to use the informations for the brush, which is these strengths map. So in the center, the weight or the strength of the brush might be the maximum, and in the border of the brush it might be the minimum. And I want to have those informations first so that I can use it to control the strength or shape of the brush. Okay, which is better if I remap this radius into 0 to 1 for ease of usage. So let's go back here and try to create that value. I'm gonna call this R or T, and you can do that by fitting or remapping the distance value. The minimum is always 0 since this is a distance value, and the maximum is, since we are inside this conditions, maximum is always radius. And now I'm going to remap this to 1.0 to 0.0. So if the distance is 0, if the point is in the center of the brush, you'll get 1. If it's outside, if it's on the border, you get 0. So this is a mistake. This is going to be 1, and this is going to be 0. Okay. Now, I'm gonna start by just using this as a linear map, okay, linearly decreasing the strengths. But later I'm going to use a ramp parameter to control the shape. But for now, this is fine. Now, let's also get the color on the previous point positions, okay, which you could do it by using UV sample, I think. Okay, so let's get the color prev col is equal to UV sample 0. Want to get the CD attribute using the point as a sample value. Then using the prev b pos prev, right? Also, I need to get the current color value as well, which you can name it as something like this. Prev now. I mean vfos now. Okay. So now that I have these two colors, it's time we mix together, but there is a chance that one point is close enough to multiple number of brushes, okay? So we need to think about that as well, right? And to do that, we might need to store all the results in an array. So let's do that. Or you can just add those color vectors you created inside one vector and create an average out of all. So let's take that path. I'm gonna create the temporal color starting with 0, 0, 0. Yeah. Now, this is the time you need to mix the color. So, the simplest way you could do is to use the lerp. Okay. Now, you have the you want to go from, you want to mix with the current color with the prev color with some kind of ratio here, okay? And this ratio could be defined by this t value, okay? If it's equal to 1, then you might just want to use previous color as it is. If it is equal to 0, then you might want to use the current color, keep the current color as it is. So you might need to change this later, but for now let's try to just use t as it is. Let's see what's gonna happen. Okay, now that I have this mixed color, I'm going to add this into temporal's color value. Add equal. Then currently I have maximum 2 brush points, and if there's a chance that one grid point is included inside 2 brushes, then you need to divide this color by 2 to get the average. So let's do that. And in order to do that, you need to know how many times you have found the brush. So let's also create additional variable called count, and each time the grip point is close to the brush, iterate the count by 1. Then finally you could divide the temp CD by color if the count is more than 0. Okay, and now finally you could apply this color information to the current color of the grid. Okay, now yeah, I think that's it. Let's see. I think this should do it, and let's see if it's gonna go well. Go outside the loop, go outside the solver and see what happens. If I play it, okay, seem to have some kind of color changes, but it's not really looking good. Doesn't really look like a smudge tool. It's just getting color and make it as a solid color. So something must be wrong. Let's try changing some values here. First off, I'm going to raise up a radius a little bit more so I can see the effect a little bit clearly, and also I'm going to raise up the speed as well. Something like 0.3. Okay. Okay, still something is wrong. So let's see what is wrong here. Let me see. So looking at this, must be something wrong with the smudge tool here. And I am assuming this here that I'm getting might be something wrong. Okay, and probably I think I might need to I shouldn't pick the current a current color as the brush positions, but instead I should just use the self color, because brush point is always constant on each frame, but so you shouldn't pick the color based on this positions, but you should pick the own color. Yeah, I think that's the reason. In those case, you might need to change this one as well, but let's see how this goes on. Okay, play it. Okay, now looks a little bit better, but it's still blurry. Doesn't really look like it's merging. So let's see what I need to do next. Okay. So let's see. Okay. Yeah, I think this thing is obviously wrong here. So what I need to do is to not pick the previous brush point positions, but you need to pick the point positions based on the grid point positions. So in order to do that, first I'm going to create the velocity, how fast the brush moved from where to where. So that is the brush current point position minus brush previous point positions. This is going to be the moving vector value. Okay. Now I'm going to use this one to sample the point positions by adding current point positions minus velocity. In this case, you're going to pick the previous point positions based on the current point, grid point positions. So by doing this, hopefully, yeah, somehow I'm starting to see some mixing. Now, obviously, if you have a dot like these, the moving speed is a bit too fast based on the brush radius. So let's slow this down a little bit. 0.1 again. There you go. So now you start to see those smudging effect. Great. Okay, looks good. Sorry for this puppy, but sorry for the experiments. Now you could try with a different brush shape and different types of parameters with these basic setup. Okay, you could go here, try to change the radius really high and see still works. Okay, and I want to test when points are close to each other and how that affect the result. So to do that, I might need to have more curves to test. Okay, so I'm going to create another one. Just rotate this. And hopefully there's some intersections somewhere. Let's set the radius to 2. Close. Close, but it's not really, not too close to each other. How's this? Okay, yep. So you see that looks pretty natural. So I think the way I have coded is okay. Now, now it's good to know. Now next, I want to try to change the shape. Okay, so to do that, what I could do is, one of the options I could do is to change these mapping value. Currently it's from 0 to 1, meaning the brush strength is going from 1 to 0, something like that, based on the radius. So by changing this to something like this or this, or might make some interesting effect. So let's do that. I'm going to reset this to 0 to 1 and going to use a ramp parameter. With this t. Now, the default shape should be something like this. Okay, 1 to 0. But changing this to something different, I'm going to change this to, okay, Bezier or B-spline and B-spline. For example, if you change this to whole 1, so the strength is always 1 on every brush point positions, what will happen? Let's see. So you see solid changes. I mean, it just picks up whole points and just pushing it. That's still interesting, but doesn't really look like smudge. What if you do have 0 on the end, but you have some curve like these, and maybe on the end you have some curve like that. And starting to get a bit more natural here. You have a bit, I can see that you're still keeping a lot of previous colors here. If you don't want to preserve previous color that much, then the curve should be something like this. It's more pointy brush. Okay, so that's interesting. Now let's talk about how you can control the threshold for the color mixtures, like if you want to keep a darker color a bit more or lighter color a bit more. Let's see how we could implement that kind of conditions. I'm just gonna go with the straight line for now. Now the place that I can set how much darker color I want to use or how much lighter color I want to use is here. Okay, and I mean, there are many ways to mix the color. If you want to do it mathematically correctly, you cannot just use lerp, but this is the simplest way, so I'm just going to use this. But in order to define the darker or lighter, you can look at each RGB values, which is from 0 to 1. And if all the values is equal to 0, you get black, meaning you get darker color. If all the values equal to 1, you get white, meaning the lighter color. So comparing each RGB value between the current and the previous color, you might be able to control how much you want to keep the darker color comparing two colors. Okay, so let's see how we could do that, shall we? So since we have 3 elements on each color vector value, we could, I'm gonna comment this out, create the loop by 3, since we have R, G, and B. Then we could say and specific element is, or has to be equal. So I'm going to compare the element R, G, and B for each previous and current color. So if the current color N is larger, meaning the current color is lighter than the previous color. I'm just looking at the R, G, and B. Then if you want the darker color, let's pick the darker one. If you want the whiter color, then let's pick the whiter color. So in this case, the current color is lighter and previous color is darker. So in those cases, I might just be okay. Let's have this here. I might just be okay by having this normal lerp. meaning if the gold color is lighter, just use the normal mixing. Else if the current color is darker than the previous one, then you might want to keep a darker color a bit more to make it look a bit more natural in those cases. And I realize I have to do this way since I'm accessing to each element. So current color, and I am also accessing to each element here, so I should just lerp between float, not vectors. And here is the point where I might want to add some parameter here. I am going to add some additional parameter here. If it's equal to 1, then oops, this t. If it is equal to 1, then you get the same value as this one, but you could make it less than 1 so that the t value will be in between, for example, from 0 to 0.5, the maximum 0.5, meaning you have a lot of chance to get the current color, which is the darker color. Okay, so let's call this how should I call this? Whiteness. In that case, you could also add this additional parameter here, calling it darkness. Is it? Maybe. Yeah. I mean, it could be, yeah, well, let's say if in this case, if you set this to 0.5, then you'll have a chance to get again these color, which is lighter. So this is called as lightness, this is called as darkness, I guess, if it's low. Doesn't make sense. Okay, vice versa. If the darkness is larger, if the lightness, okay, I don't think I should have two. It's a bit confusing. I'll just try with just one, and you can add it by yourself if you want. Okay, some error here. Am I missing something here? Okay, so if it's 1.0, that's the same as previous setup. But if I set this to 0.5, we're going to pick more darkness between two colors. See what happens. Oop, that's too black. Maybe I'm missing something here. Think I did something wrong here. Let's test with these setup. This should be equal to the one that I wrote here. If not, something must be wrong. Yeah. Okay, let's see. Current color, previous color. Yeah, and I'm updating. Okay, should be okay. For loop. Am I okay to use n? Yep. Let's see. Oh, okay. Something must be wrong, and obviously something somewhere right here is wrong. Let's see. Let me see if this works. Temp cd. We do have temp cd, right? lerp call prev call t. So this is the previous version. Let's fine. Comment this out. Okay, so this works. Now, how is it that this is not working? Let's see why. Okay, this should run for sure. And this is just checking the brightness on RG and B. Spell is correct. Name is correct. You are allowed to use lerp between the float. Sorry. Obviously, something is wrong. Let me see. So we have temperature curve. What if I don't divide it? No, nothing happens. Looks like it's just pick black color. Meaning these values not being updated somehow. Somehow. So something must be wrong here. Let's change. Oh, here. Conditions. That's where I did wrong. Okay, so everything should be N. I was mixing I here. That's the reason. Okay. That should be okay, and I'm going to multiply this one right here. There you go. Okay. So this is when the lightness is 0.5. Let's check. I'm gonna screenshot this for a comparison. And then going back to here, change this to 1. See what happens. Play it. Okay, screenshot this. Okay, now you have this is where the lightness is 0.5. This is when the lightness is 1.0. So you do see some differences here. Right? You do see more darker color being used. So that's that. And same as that, you could add additional parameter here, I guess. You might call this darkness, maybe, not sure. But this is, yeah, let's see what's gonna happen. Not sure what's gonna happen here. So if the darkness is 0.5, everything has become brighter, I guess. Let's test. So you have less usage of darker color and gonna use brighter color more in this case. Okay. I mean, the name of the parameter is a bit wrong in this case, I guess, but yeah, that's how it works. The default is everything is equal to 1. Okay, I'm just gonna keep it as it is. So now that I have a 2D setup like this, let's extend this to a 3D, shall we? Okay, thank you everybody for the comments. Okay, so 3D. Let's organize this a little bit more before getting into a 3D. I mean, it's pretty simple to set up for 3D. You just need to use extra steps to move the brushes based on the normal, I mean the tangent directions and so on. So yeah, it's pretty simple. It's pretty versatile. Now this is important. This here is important. Let's name this brush point. Name this grid or object or geo. And this one here is the brush stroke. Okay. This is just a curve. And the curve goes till here. Maybe including this one as well. This one come here. So all these are custom. You can change it by yourself. Okay, so in terms of 3 dimension, let's try using pig head, shall we? Now, I'm gonna scale the size so that it's relatable to the grid. Somewhere around here. Okay, now one thing about 3D geometry, when you want to mix the color, you do need to use a attribute in my setup. You cannot just use the texture color directly, so you have to transfer the texture color to a point as a color attribute. So that's what I'm gonna do first. So in order to do that, the number of points right here, right now, with this pig head is a bit too small. If you want to have a high res smudge effect on this geometry, you need to have a bunch of points instead of using this texture. I mean, if you just want to deal with the texture itself, I think it's better you should use shaders instead of Houdini approach. But if you want to use a geometrical approach, then you do need to have a bunch of points if you want to do it directly on 3D. So let's do that by using remesh first to have a bunch of points. And although the same idea could be used for shaders, probably, I'm not sure. Maybe. Maybe not. So first I'm going to subdivide to make it a bit more smoother overall, then use a remesh to have a bunch of points. Now, how many points do I have right now? 12,000. Previously I have like 100,000, 130,000. So let's make this a little bit more points. Okay, 50,000. I think that's enough for testing. Now, currently, as you can see, the color is not good. It's not really transferring. I mean, this is just texture information, so it's not really a color information. So what I want to do is to transfer the color information from here to here somehow. Let's do that. First thing first, I'm going to delete the texture attributes since I'm not going to use it for this one. So delete the material and UV is broken up, so I cannot also use it. So instead of using UV to get the sample out of this textures, I'm going to use UV sample, I guess, in a code. Okay. All right, so let's do this. I'm gonna use point wrangle. So the way I'm going to pick the color from the original geometry from these textures, there's a function called color map, which you can sample the color from the texture. So that's what I'm gonna use, and let's see how we can use that by looking at the document. That's the shader code, but you can also use it in SOP context. Okay, this one. Okay, so this function does bilinear interpolation of the pixel values, and you need to have a file name for the textures and UV to retrieve the color informations. Okay, simple as that. So you need to have a path to the texture of this pig head. So in this case, if you go inside the pig head, there's a material like these, and there's a shopnet right here. On each shopnet and each material, the texture is applied here. So, and this shows where the texture is. So I'm going to try to get this parameter value and use it as a texture path. Okay, for each point. Okay, so we have three material. And one thing to notice is that this eye doesn't have a texture value here. It only uses color. So let's just get color information and the texture information and multiply those two values together to get the actual color. I mean, if you want to make it a bit more natural, you also need to get specular color and so on, but in this case I'm just going to pick the basic color, right? So to do that, first thing first, I'm going to get the sample information by using UV, the XYZ distance, which is one of my favorite functions. So second input is the original geometry, and for the second input, I'm going to use P as a sampling point positions and prim UV. I'll put the primitive and UV. Now by using these prim and UV information, you can now get the path for the material. Now prim 1 shop material path. This is the path to the shop material. If you look at the geometry spreadsheet on primitive, you have this attribute here. This is the path to the node. You see? Now this is not the path to the texture. It is just to the path to the material itself. So you have to get the texture using this together with the name of the parameter. So shop path is equal to prim. Okay, now the texture path is equal to this primitive. Well, texture path is parameter value, so you need to use ch related functions. In this case, a path is a string, so I'm going to use chs. And first I'm going to enter the shop path, then the name of the parameter for the texture. Now let's check that out. For the pig, the texture, the name of the texture, it says parameter equal to base color underscore texture, so that's the name. Okay, so you could just add slush base color texture. Okay, and hopefully I think I'm missing something. CHS. Oh, it's fine. Now let's check if I'm getting the value that I'm looking for, the path for the texture. Check the points. There you go. So this is the path to the JPEG texture image. So I'm getting correct. Now for some part you are missing the texture. That is because as we see, material doesn't have a texture. So in those cases we need to have the color as well. So let's get that. Vector color is CHS. I mean in this case CHV. Shop path plus what was the name of the color parameter? So looking at the eyes, base color, it says the parameter is base color R, base color G, base color B. So if you just want to get it as a vector, you can say base color. So simple base color. Okay, let's check that as well. Oops. Okay, so C call says, okay, so we do have different colors retrieved, so that's good. Now we can retrieve the color from this textures using this primitive number and UV value. That's where we want to use the function called color map. Okay, so let's do that. So let's write it here. Vector text call is color map, the file path, and UV, in this case this one. There you go. Yeah. So we have two colors. We're gonna multiply these together to get the final color. Okay, and replace the current color with his final color. See what happens. Oops, did something wrong. Okay, let's see where I did wrong. I am getting, well, let's just replace this with text color if I'm going. Okay, so this is wrong. Color map here is wrong somehow. Okay, let's see where I did wrong here. So I'm getting the texture color for sure, so maybe the UV is wrong somehow. Let's see if I need to set the color space, source color space to auto. Nope, that's not it. Okay, well, let me check. So, I have the point. I have this point information, getting the primitive and UV. Let's see if I'm getting the right information. Okay, I'm gonna use the prim UV by using the output primitive number and UV. And then if I change the current point position with this positions, should not change its position. So that's correct. Okay. Okay, now what else? Or this one is wrong. Let me check again. Big texture name here. Base color texture, so should be okay. Should be okay. If you like compare with this one and this one, yeah, the distance is close enough. So you should be able to get the samples like this. Now, what am I doing wrong here? I see. Now I get it. You cannot use this UV because this UV is based on the primitive, and it's not related to the UV stored as an attribute here. The XYZ distance UV is not this value, but something different, which only works on per primitive. So what you need to do is to get this information instead. So that was the problem. Okay, so to do that, you could use UV sample. I'm gonna call this GeoUV, UV sample. And what you want to get is the UV using point position as the sampled value, sampling value. There you go. Or the other way to write is using prim UV, getting the UV using prim and UV. So either way, I think you can get the same value, which is this one. Let's try using the latter one. Okay, now so if I change this to GeoUV, I shouldn't change these positions. Now that I have this new UV, what I want to get is the color value. So wait, has to be written here, and this GeoUV has to be used here. Okay, now finally update the color with the final color. There you go. Now I have just transferred the color from the texture to the point, and each point has its transferred color information from the texture. Okay, that's good. Now after that, it's pretty simple. I mean, this is pretty much the same as this setup that I did for 2D, so you could just switch between those two. Now next, you need to create a brush. In this case, this is a 3D geometry, so you need to create the brush on top of this 3D geometry. So as I did in the example, let's try creating a stroke which goes from top to bottom like a raindrop stains, which going to create a raindrop stain like shape, merge, color mixture. So instead of using these 2D curve, let's try creating a 3D curve. I'm gonna use the same switch here. Let's have this copied, paste it here, or not. Okay, so to create a 3D curve, 3D brush, what I'm gonna do is to first of all measure. Maybe I'm still gonna link this switch to this one. Okay, and going to calculate the gradient of this geometry. Let's switch this to 1. Gradient gives you a gradient vector value based on the specified information, specified attributes. In this case, I want to go from top to bottom, so I'm going to use the y component of p, which will give you these vector flow. In this case, going from bottom to up, but we can just multiply negative value, then it's going to go down. Okay, now from this, you could use this information to create the stroke curve from top to bottom, I guess. So let's do that. I'm gonna create a bunch of points on top of this geometry, which is going to be the starting point for the stroke. Let's say 40 points. Let's make this non-relaxed. Okay, and then let's think about how we can create the curve. Now, you could do this in Solver, but instead I'm going to use a for each loop, specifying the feedback loop number. So let's say I'm going to loop for, I don't know, 40 times. Make this feedback loop to move the point to create the stroke. Connect this point and create the attribute for each point, specify the stroke number. So okay, now you could just move those points based on the gradient, direction, and some speed, and that's it. And connect all those points together to create it as a stroke. Okay, so, and I guess I'm going to make it as merge each iterations for this one, so that I don't have to do some complex stuff here. Move by gradient. Now, let's sample the gradient from the input. I'm gonna use UV sample. Get the gradient using P as a sampling value. Okay, now that I have to get the gradient, you might want to make it negative to go downward. Also, I'm gonna normalize this so that point moves in the same speed. Now finally, multiply by a specific speed. Okay, say 0.2. Oops. Now you can now just move this point to the gradient direction, and that's it, I think. Let's see. Right, and now you have a trail. You can now add these together add these points as a polyline using add node shares the same stroke number. Alright, there you go. Okay, I think that's it. Now that I have these curve, and let's also make sure that it is stick to a geometry by using ray node. Minimum. Okay. And now you should have a clean falling down stroke. And connect it here. Okay. And everything else should be the same, I hope. Yeah. Let's see. Now, let's test. We have a bunch of points. If I run it, maybe the brush size is a bit too big, but you see that the pig head is melting. Okay, let's reduce the size a little bit. There you go. There you go. And that's pretty much it. You can increase these values. This might gonna be heavy. No, this doesn't really gives me any better result. I should either increase this one. Is it? Is it increased? No, not this is just a seed. This one. Yeah. Alright, so if I have this number of points and the stroke actually looks like these. Okay. As a result, something like these. Melted pick. That's it. And hopefully I can swap this pig head to something else like rubber toy. Still works the same way, hopefully. That's a bit too small. Okay, let's try with these. See what happens. Now I can turn on the light. Yeah, still works. I mean, everything is blue, so it's a bit hard to see the mixture, but I think it's still working. Leaks in the bottom. Okay, so that's it. That's it for today. This is how I implemented the Smudge tool, both for 2D and 3D. Okay. Let me know if you have any questions. If not, I would like to end here. As always, I'm going to upload the file to a upload the files and share it on a YouTube description page so that you can play out with it after the live stream. Right. And I'm also using Patreon, so if you would like to support me, that's really great. Okay, that's it for today. If no questions, I'm gonna end this here. Thank you everybody for coming. Good night and have a nice week. Before finishing this, I'm going to organize the parameter a little bit, since everything is inside the solver. And I gather all the parameters that's important inside here. I hope you liked it. I hope you found something new here. I wish. Okay, let's change this to toggle. Where's the toggle? And what else? The resolutions, I guess. Oh, you can. It's not that important. And yeah, what's important is here. First of all, the brush size, brush speed. Brush size, really using with the randomness. And the stuff. First of all, the ramp parameter, brush shape, or yeah, not the shape, brush strength. And lightness. Okay, that's about it, I guess. Everything else. Okay, so if you, let's make this a polygon, low res. Well, you could see how the brush moves here, but doesn't really look like a brush. Well, okay. And this doesn't also shows the real radius of the brush, so you might need to update the brush P scale, which is gonna be used with the copy 2 point. There you go. This is more like it. Okay, so, and this will be the final. And the bottom one is just to test the result. Yeah, I think that's pretty much it. All right. Thanks for the question. Thanks for the live eye. Can this setup be used to drive something like a displacement for the geo? Yeah, for sure. I think you could do that. I mean, you just need to change the displacement related attribute instead of color to do that, I think. In this case, it doesn't store the additional attributes in this case, but let's say you have a additional attribute instead of color, something like D or disp or displacement related value to this grid. I'm just gonna do this as a test. Am I gonna delete it after this? Float point, start with the 0. Okay, and inside you could go here. Well, if it's all 0, I guess it doesn't really mean anything because it's not gonna mix anything, so probably better you make something noisy for testing. Yeah, something like that. Change this to displacement. Now go back here, and also as a test I could use that displacement geometry, value, to offset it into a normal direction to see the effect. So currently that's too much. It's a bit hard to see. Might need to have a bit more, change the element size a little bit more to make it wavy. Okay, and make sure to normalize this again. So currently I have this bumpy surface, and try to mix these bumpiness with this setup. Now where do I do that? We can go into Smudge tool and do the similar things that I did here. So temp disp, start with the 0. And then do the similar calculation. Temp disp plus equal lerp you need to get the current displacement and the previous displacement just as I did here. So and pref disp, these all float, and you don't want to get the color, but instead you want to get the displacement here. Everything else is the same. Now current disp to prev disp and t since this doesn't have any darkness or something, the kind of information, I'm gonna skip here. So, and I'm going to make the average of this displacement same as I did for the color, and then update displacement. Think that should do it. Let's see. If I play it, you see the displacement has been mixed between the previous stroke positions and the next stroke positions. You're seeing something something ugly here. Well, not sure if that's what you were looking for, but you could use this technique to deal with any vector value or float value. Okay, now that's just testing, so I'm gonna leave it here if you're interested. I should make a comment for that one. It's not really related to the main topic. Okay. Okay, so that's it for today. Thank you for joining. Appreciate all the comments. Now I'm gonna go to sleep. I'm gonna end this live and upload the files, and you can play with it. Good night, everybody. See you soon. Hopefully next week.